The real number system is a way that we identify numbers based on common characteristics. Just like we may identify each other as male and female, tall and short, we would identify numbers based on different characteristics or different things that they have in common. And so as we look at the number system, it's divided into 7 major categories. Now, as we work our way down this, we're going to do a definition, an example, and then a non-example of each of these numbers. Natural numbers are the easiest for us to identify. We can call these counting numbers. So when we start counting, we start with the number 1, and then we go to 2, and then 3, and so on until we've counted however many items we are trying to identify. Non-examples: negative numbers, decimals, and fractions. While it might be possible to count with decimals and fractions, that's not the normal way we would count. And so we're going to go with just the simplest form of this definition. We count starting with the number 1. Now, whole numbers are going to include everything that's a natural number, and we're going to add one additional number. So these are non-decimals, positive numbers, and 0. So that means we start with 0 and then we add all of the counting numbers. It's non-decimals and they're positive, so if a number is negative, it's not a whole number. And if it is a decimal, it is not a whole number. When we move on to integers, these would be the numbers written on a basic number line. Now we can create number lines with all different representations, but a basic number line would be negative numbers, 0, and then positive numbers. So when we're thinking of integers, think of basic numbers written on a number line. The non-examples then would be anything that's not one of these numbers. So that means decimals, positive and negative, fractions, positive and negative. Now, rational numbers are going to be numbers that can be written as a fraction. So that means some numbers can be positive, they can be negative. So for instance, 1/4, which is 0.25, is a rational number. 1/3, which is 0.3 that repeats, that's also a rational number because it can be written as a fraction. A non-example would be pi. Pi cannot be written as a fraction, so it is not part of rational numbers. The square root of 2 is a decimal, 2.8, and then it's going to be a whole bunch of decimal places after that. It cannot be written as a fraction, so it is not a rational number. Irrational numbers are going to be decimals that do not repeat and never end. So our best example is pi, which is 3.14159, and then it keeps going forever without repeating the same digit over and over again. There is no end to the number. A non-example would be any fraction that we can write that terminates, meaning there's an end to the decimal. 1/4 is 0.25. That's the only decimal places that it needs. Or 2/3, which is 0.6 that repeats. Since it's a repeating decimal, it's rational, not irrational. And then real numbers are all numbers that we study this year. Okay? So all numbers are examples. The non-example is the letter I, And you'll learn about that in high school. It stands for imaginary numbers. It is a category of numbers that we will see in the future, but we don't focus on them in 8th grade. So now what we want to do is place these examples on the graphic organizer at the bottom of the page. So we want to label the graphic organizer and place the examples in each set. So if we notice here, this outside line is everything. So every number that's inside here is going to be a real number. So we could call this the real number system. Okay? Now, when we get inside here, we would label the big group real numbers. Then it's divided into 2 major categories. We have rational numbers on this side, and we have irrational on this side. Irrational has no other subgroup, so this is pi square root of 2 for our examples. Rational numbers, 0.25, 1/3, 0.6 with the repeating sign. Inside of that is going to be the group that is integers. So -3, -2, -1, 0, 1, 2, 3. Then we have whole numbers, 0, 1, 2, 3. And then we have natural numbers, starts at 1, 2, 3, and goes on. So every natural number is a whole number. Every natural number, every whole number is an integer. Every natural number, whole number, and integer is a rational number. Every natural, whole, and integer, and rational is a real number. So the smaller groups are always a part of the group that they're inside of. Now there can be other numbers that don't fit. So 0 is not a natural number, but it is a whole number. Now everything else in this set is a member of this subset. -1, -2, -3 are integers, but they are not whole numbers or natural numbers. So they are not members of the subsets, but they are a member of integers. And then from 0 moving to the right on our number line would be all the numbers that are parts of these subsets. So understanding the relationship between these numbers is what's really important. The big thing for 8th grade is being able to identify the difference between irrational and rational. So rational is a terminating decimal, meaning it only has a couple of decimal places, or a repeating decimal, the same digit repeats over and over again. Irrational is going to be something that does not end. It goes on forever, but it's not the same digit repeating over and over again. Make sure you copy this on your notes.